Hello students, now let us try to understand the measurement of the internal energy that is delta U and enthalpy that is delta H of the chemical reaction. How can you measure that is change in the internal energy and change in the enthalpy? Okay, so dear students, to understand this one we have to understand that is the bump calorimeter and the some other type of calorimeter for the combustion reaction. Then only you will be able to measure the delta U and delta H. So let us read out the slide and try to find out the what are the points are there. So delta U is determined at a constant volume and delta H is determined at the constant pressure. So enthalpy is determined at the constant pressure and internal energy is determined at the constant volume. So because delta U is internal energy and that is what is constant volume, and enthalpy delta H is there and that is constant pressure. The technique for measuring heat of the reaction is called the calorimetry. How you are measuring the heat of the reaction, that is in the based on totally calorimetry. The apparatus used is called the calorimeter. Okay, apparatus used for the calculation of the heat is known as calorimeter. Water is the calorimetric liquid. In the calorimeter, what the solvent you are using, that is water. Depending on the type of the chemical reaction under study, two types of calorimeters are being used. First one is bump calorimeter, second one is water calorimeter. How is the bump calorimeter? The first type is used the combustion reaction. Means bump calorimeter is used in the combustion reaction, and the second type is used in the other type of the reaction such as dissolution of solid in water and neutralization reaction. So let us try to understand the first type of the bump calorimeter and the first type of calorimeter for the combustion reaction, that is the bump calorimeter. This type of calorimeter is known as the bump calorimeter. Here is the diagram student for the bump calorimeter. Here is what is thermometer is fitted here on the right side of the container, and then you will find that is the there is the oxygen pump is there, which is pumping for the combustion reaction. Sample has been taken inside of the, and the pump is there downside. Water and stirrer are available in this one. So the bump is calorimeter is made up of steel coated inside with the platinum or the gold or some other non-oxidizable metals. So that is how it is coating in the bump calorimeter is there, that is non-oxidizable non-oxidizing metal, like what is they are saying platinum, gold or some other metal. A known weight of the combustible substance ignited by passing electric current through the platinum wire. The substance undergo the combustion and the heat is liberated. Increase the temperature of water in the calorimeter, thus rise in the temperature measured accurately using the sensitive thermometer, that is Bachmann thermometer. Okay, so when you are heating the sample through the electricity and electricity is passing through electric wire, so that is when the combustion reaction taking place. So at the accurately we can use the measure the heat by the thermometer, and that thermometer is the sensitive thermometer known as Bachmann thermometer. The heat capacity of the calorimeter is determined using the known weight of a given chemical substance prior to the main experiment. So okay, again you read out this statement student. The heat capacity of the calorimeter is determined using a weight of the given chemical substance prior to the main experiment. The heat of combustion of benzoic acid is minus 3226 kilojoule per mole. Let us do the calculation student. How can you do the calculation? Let us theta b rise in the temperature of the water. Let us theta b rise in the temperature of the water in the calorimeter after complete combustion of the experimental substance. The weight of the substance is m grams. The molecular weight is capital M. The heat capacity of the calorimeter plus water is total calorimeter, that is system Z. Okay, so what could be the formula student? The heat of the combustion is delta U is equal to Z into theta into capital M by small m, that is giving rise the negative. Okay, where theta is that is T2 minus T1. If heat capacity of bomb separately given, that is Q is equal to Q bum plus Q water. So Q is equal to C bum delta T plus W water dot CS water delta T. If ice is given in bum calorimeter, if ice is given in bum calorimeter, Q equivalent is equal to delta S fusion ice into number of mole of water. Q equivalent is equal to L fusion ice into mass of water, formed in gram. In the above experiment, the volume is constant, hence heat of combustion is at constant volume, that is QB. QB is converted into QP using the equation. So QP is equal to QB plus delta NGRT. Delta H combustion is equal to delta E combustion plus NGRT. Delta NG change in the number of gaseous molecule in the combustion reaction. How we calculate, that is delta Ng is equal to NP minus NR. So gaseous NGP, gaseous product minus NGR. T is equal to T1, that is experimental temperature. There is, after the bump calorimeter, there is another type of calorimeter is also being used, student, and that is the what is used for the neutralization reaction. It is used for the non-combustion reaction such as solution of the salts, organic compound in water, neutralization reaction. This calorimeter contains two beaker, one placed inside the other one. In between two beakers, non-heat conducting material is placed. Okay, this calorimeter contains two beakers, one placed inside the other one. In between two beaker, non-heat conducting material is placed. Dever flask also can be used in the calorimeter. Dever flask can also be used in the calorimeter. Water equivalent W of the calorimeter together with the stirrer and the thermometer is the measured first. Water equivalent W of the calorimeter together with the stirrer and the thermometer is measured first. Okay, so this is the second type of calorimeter. Now we will try to understand the some problem based on the bump calorimeter, and that is second type of calorimeter where the sublimations and the neutralization reaction is taking place. Thank you so much for watching, friends.